Hello, today we're going to go over increasing and decreasing functions and local maxes and mins. So what we're going to first look at is just some examples. And I think as we go through the examples, you'll catch on what we mean by increasing and decreasing as well as local max and mins. So our first example here, I'm just asking you, is the function increasing or decreasing? So what do I mean by that? When we're asking increasing or decreasing, I want you to go left to right. So look at your x values, and as x increases, so as we go from left to right here, do my y values increase or do they decrease? So every time we're talking about increasing and decreasing, you're moving left to right on the x-axis and describing is the y value, or in other words, is the function's value going up or down, increasing or decreasing. So as I go left to right here, notice my y values are going up. So this is an increasing function. I'm just put I and C for increasing. As I look at number 2 here, going left to right, so as my x values get larger, my y values are getting smaller. So the function's value is decreasing as the x value gets larger. I'll put DEC for decreasing. Not because I can't spell it. I'm pretty sure I could spell it. It's just there's not enough room to write it in there. All right, number 3 is a little difficult to probably see there, so I'm going to trace it out in red. And it's actually a line right here. Because it's on top of the graphs line, it's hard to see. So it's asking, is this increasing or decreasing here? Notice as my x values increase, my y values don't go up, but they also don't go down. They're saying constant. So we do have a third option here, and it is constant. So a function can be increasing, decreasing, or it can be constant. Take a look at number 4. So number 4, as my x values increase, my y values, they are also increasing. This is increasing. Number 5 here, as my x values increase, my y values are going up. This is increasing. Number 6, once again, it's hard to see, and that should clue you in. That's going to be like the one above it. That is a constant. Number 7. So number 7, as my x values increase, my y values are decreasing. And then number 8 here, once again, that's a horizontal line, so it's neither going up nor down, so it's constant. And number 9 is x values increase, my y values are decreasing. So I think most students get the hang of that pretty quickly. Notice all of those are linear functions. So they're increasing everywhere, decreasing everywhere, or it stays constant throughout the whole domain of the function. But we don't always have linear functions, do we? So as we look at things that are nonlinear, then we can have increasing, decreasing, constant, all in the same function. So let's take a look at some other numbers here. So take a look at number 10, and you may or may not be able to see all the directions there. My face is kind of in the way. It says for each nonlinear graph, use interval notation to tell whether it is increasing and decreasing, and identify any local maxes or local minimums. So those are some new vocab terms here, local max and local min. And all we mean by that is if we have a function like number 10 here, where it's decreasing, 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 and then all of a sudden it starts to increase, well, we switched from decreasing to increasing, so there must be a minimum in here, or a local minimum. And what they mean by local minimum, they just mean that within these x values here, there is a minimum value in the function. We had to switch from decreasing to increasing. The reason why they use local is because some functions go up and down all over the place, and so you have several minimums, several maximums. When we say the absolute highest or the absolute lowest a function can go, we call it an absolute max or an absolute minimum. But sometimes, here, let me draw one out for you. Let's see. Let's suppose we had a function that looked something like this. Let's just sketch one out real fast so you know what I'm talking about. We could have a function that looked something like this. And so, yes, this may be the absolute maximum, but we also have local to, here, let's draw an x-axis here, local to these x values down here, there's a small maximum right there. The function's going from increasing to decreasing. So we do have a local max there and a local minimum here, even though the absolute max and the absolute minimum are right in there. So you may not know if a function has an absolute max or an absolute minimum. You may not know where it is. When you get to calculus, you can learn how to calculate those things algebraically. All we're concerned about today is drawing these things out based on a graph. Can we find a local min, a local max, and tell where a function is decreasing or increasing? So as we look at this, these are the three things I want. I want to know what intervals is the function decreasing, what intervals is the function increasing, and what is the local max or minimums in that function. So here, when I list out when it's decreasing, you have to list out the x values. Make sure you're giving me the x values and not the y values, okay? So our x values here start at negative infinity and they go to, it looks like -3 right there. So we're gonna write this in interval notation, negative infinity all the way to -3. Now, whether you include the -3 or not on something like this, it doesn't matter to me. So in this case, you could put parentheses or you could put bracket. And I believe I checked on the homework in Delta Math. It shouldn't matter either. But if it does count it wrong, let me know and I'll be sure to go back and correct it. So I'm just gonna leave it as open parentheses just to be consistent. But we're gonna say that it is decreasing along the interval from negative infinity to -3. And then it starts to increase. So it's increasing from -3 to positive infinity on my x-axis here. So that's where it's increasing. There is a local minimum right here at -3. So we can say this a couple different ways, or it can be asked a couple different ways. You can say, where is the local minimum? And I can say the local minimum is at x equals -3. Or it could ask, what's the function's value at the local minimum? Be careful with the wording there. The function's value is our y value. So in this case, our y value is at -7. So the f of -3 equals -7, right? And we'll talk about, if you haven't seen function notation, go back and watch my video on functional notation there. But we can write this as an ordered pair. That would work. In Delta Math, if you have an assignment for me in Delta Math, what they're looking for is they're looking for that value -7. So if it asks for the function's value, it wants you to put in the x value where the local minimum is. If I'm just asking where is the local minimum, you put x equals, the x value basically, x equals -3. All right, try out number 11. Where is it increasing and where is it decreasing? So notice this one has a local maximum because it goes from increasing to decreasing. It increases along these intervals, it decreases here, it has a maximum right there. So we are going from negative infinity to, it looks like 2 is where our value is. So it's increasing from negative infinity to the value 2 there. And then it's decreasing from from positive 2 to infinity. And then we have a max at x equals 2, or you can say the function's value there, if it's asking for the function's value like it will in the homework, at x equals 2, y is equal to 5. Try out number 12. So number 12, see here, it goes from increasing, and then right here it's decreasing, and then over here it's increasing. So it increases from negative infinity, remember we're listing x values, all the way up to this value here of negative 3. And then it decreases, so we got to write down decreasing from negative 3 all the way to, this looks like positive 3 here. And then it switches to increasing again. So we got to write up on the row that says increasing here. We're going from 3 to infinity. So we've got 2 spots where it's increasing, 1 spot where it's decreasing. I'm going to have a max at x equals negative 3 and a min at x equals positive 3. And remember on Delta Math, I'll remind you again, they're going to ask you for the function's value. So they want the y value there. So the y value would be, it's hard to see, but it looks like 22. Notice the scale is different here. So y value of 22, and then the x value here, the y value at x equals 3 looks like negative 14. All right, try out number 13. So number 13, notice the shape looks a lot like number 12. These are our cubic looking functions here. In fact, number 14 looks like it too, where we're going increasing, decreasing, and then increasing again. So for increasing, it's increasing from negative infinity all the way up to negative 4. Then it decreases from negative 4 all the way to 2. Right here is x equals 2. Remember, we're giving x values, not y values. And then it goes from 2 to infinity. It's increasing. Oops. All right, we have a max and a min. So our max is at x equals negative 4. And our y value there, the function value, looks like it's going to be somewhere between 16 and 18. So I would say 17. It's hard to tell. On the homework, you'll be able to tell a little bit easier. It's easier to read. And then the minimum value, let's see, is right here at x equals 2. And y equals, it looks like, negative 19. All right, let's try out 14. So number 14, we're going, let's see, we're going to increase right here all the way up to the value of negative 3. So it's increasing from negative infinity to negative 3. And it's decreasing from negative 3 to 1. So right here is negative 3, right here is 1. So we're reading our x values where it's decreasing. And then from 1 to infinity, it's increasing again. We have a max here at negative 3. Sorry, not a max, a minimum here. Nope, had it right the first time, it's a max. Sometimes I'm going back and forth, making sure I'm matching up with my answer key as I do my notes, and sometimes I mess up. So this is a maximum, right? Because it goes from increasing to decreasing. So at negative 3, we have a max. And our y value there looks like it's 14. Our minimum is going to be over here at x equals 1. And the y value there is, it looks like, let's see, it looks like it's going up by 2s there. So I would say 3. Once again, the homework will be a little bit easier to see, and you should be able to zoom in some if you need to, because it'll be on the computer. All right, let's look at number 15 here. 15 is that parabola look to it, and it's been flipped upside down. It goes increasing, then decreasing. So we have just one local max, and this thing increases from negative infinity all the way to -4. And then it decreases from -4 to positive infinity. And we have a max. It's at x equals -4. And it looks like the y value at -4 is +7. Oh, I'm writing all this stuff and you can't see it, can you? There it is. All right, let's take a look at number 16. I'll see if I can write this where you can see it. So number 16, this has got an exponential look to it. It goes through 0, 1. This is, you can't see it, maybe not so much right there, but this is a horizontal asymptote at y equals 0. So as you go towards negative infinity, this function gets closer and closer and closer to the x-axis, but never quite reaches it. And then over here, this thing grows forever upwards. And so our domain here is all real numbers. Our range is everything greater than 0. But as far as increasing or decreasing goes, we're going to say it's increasing from left to right, because even though it never quite reaches the x-axis, it gets closer and closer as you go towards negative infinity. So this is getting closer as we go this way, so it is constantly increasing. So it increases from negative infinity to infinity. You give me a point right here, and then another point right here, and going right to left, it's getting smaller, or from left to right, it's getting larger, and that's why it's constantly increasing, okay? There is no max or min here, because notice for all the others to get a maximum, you have to go from increasing to decreasing. That gives you that maximum. To get a minimum, you have to go from decreasing to increasing. That gives you the minimum there. Since this thing is increasing everywhere, it never switches between increasing and decreasing, and therefore has no max or min. All right, let's look at number 17 here. So number 17 looks more like a logarithmic type function here. And so it's getting really close to the y-axis, never quite reaches it. So our domain, if we're talking about domain, is anything above 0. And our range goes from negative infinity to infinity. So it's the opposite of the exponential, and there's a reason for that, the domain and range being opposites, and that's because they're inverses to one another. Those are all things we'll talk about later, so don't worry about what those mean if you don't recognize them. So anyway, our concern is it increasing or decreasing? Well, it's increasing. And in this case, we are increasing from 0. Notice it's not defined to the left of 0, so you can't be increasing or decreasing over there. But we are increasing from 0, not including 0, going out to infinity. There is, once again, no max or min here because it never switches between increasing and decreasing, so we stay no max or min. One more here. Notice this function right here. It is going from negative infinity to infinity as far as the domain is concerned, and it is constantly decreasing. So we're going to say it's decreasing from negative infinity to infinity. There is no max or min here because I know some students look at this and they want to say there's a minimum in there, but the function never increases. It's always decreasing. So if it never increases, it means that if you give me this point right here, let's say you want to say, boom, there's my minimum. It's right there in the middle, just like a parabola. The problem is if I move one spot to the right of it, I can give you a y value that's smaller than the point you give me. If I move again to the right, I get another y value that's smaller. It's getting smaller and smaller and smaller, the y value that is. So it is constantly decreasing. There is no minimum value there, all right? So that takes you through the back page there, if you downloaded that page, with the increasing, decreasing in those intervals. Let's look at a few more over here on Desmos that I want to share with you. So if we switch to Desmos, I've got to log back into my computer. This is what we get right here. And I've got several functions I want to look at and for you to practice on your own here. So the first one, let's look at f of x, and you can copy this code if you want, if I haven't shared it with you. But this is what it looks like. So is this function increasing or decreasing, and on what interval? The nice thing about Desmos is we can click on points and see where it starts. It looks like it picks up at 4, and that makes sense. There is a shift to the right at 4 up in there. And it goes on forever this way. Now, if you click and drag, it gives you the y values and the x values for that matter, but we can see, pay attention to the y values, you see that they are getting smaller and smaller and smaller. 0.818, 0.817, that thing's getting smaller. But notice as we drag it out to the right here, it's now at 0.842. So although it may look like what we had a second ago, it looks like it's getting closer and closer to the y-axis. It's actually increasing. In fact, we can test this. If we go down and now name this function f of x, if we type in, say, the f of 100, notice the value is 0.916. So it's getting larger as you go out to the right, except for right here at the beginning. At the beginning, it's getting smaller. And notice when I click and drag, see how it brings up this little point right here? I didn't put that in there. This is Desmos automatically identifying for you a local minimum. So this thing is getting smaller and smaller and smaller to hits right here, and then it's getting larger. So we could write it's decreasing from 4 to 8, and then it increases from 8 to infinity, and there's a local minimum right here at 8, or the y value is 0.816. So I don't expect you to see that on a graph paper like I just showed you and said, oh yeah, it's definitely increasing. But I want to show you that in Desmos, we can analyze these things. Let's look at another one. If we had the g of x right here, obviously that is increasing from negative infinity to infinity. It's kind of like the first few examples we did. And then we've got this fun one right here. This one is a linear piecewise function. We got two different linear equations. It goes from negative infinity to 0, it's decreasing. And then from there on out, from 0 to infinity, it's constant. Let's look at x squared minus 2. This one decreases and then increases. It has that local minimum right there at 0, negative 2. This one, we did plenty of those, so I'm not going to go through that one for you. But once again, you could look at these and analyze them just the same. I think that pretty much covers it. E to the x, we'll discuss later on, but it's just like the one we saw a second ago with the exponential function. But I've included these graphs right here. I'll find a way to share it with you. So you can go through and not just look at it over here on the paper or on your Delta math assignment, but you can also look at it in Desmos and add your own functions if you want to. I would suggest as we do Desmos, notice how I've got it saved as increasing and decreasing. So if I share this with you, or anytime I share something in Desmos with you, if I haven't already named it, name it appropriately, and then hit save the graph there. Now I don't want to include a duplicate because I'm happy with the way this is. But in order to save the graph, make sure that you're logged in under your Bedford County ID or whatever you use for Desmos. Log into that. And then over here, notice I've got all these graphs saved. Of course, I have a lot more saved because I'm a math teacher, but I got all these saved so I can go back and look at them. You can save them so you can go back and look at them when you go to study. Or if you're watching along with this video for the second time and you want to see what we're doing as you prepare for something, you've got them saved forever there, okay? So that covers increasing and decreasing functions, writing those out in interval notation. It also covers local max and mins, all of it analyzed graphically. Go through and try the sample problems and let me know if you have any questions, okay? Thank you for watching.